In this video, the learner will determine the surface area of prisms and cylinders. First, we're going to label the parts of this rectangular prism. So we know that we can choose two of those rectangles to be our bases. On each of those bases, we have the base edges. So the edges of those bases are called base edges. Then the other four faces are called lateral faces, so the front, the top, the back, and the bottom. And then we have the lateral edges that connect those two bases together. And then the corners are all called vertices, so we have 8 corners here. Go ahead and label all of these parts on the triangular prism that you see in part B. Now let's talk about what lateral area and total surface area are. When we say lateral area and total area, we're talking about the area of the surfaces of those three-dimensional figures. The lateral area is the sum of the areas of the lateral faces. So notice in each one of these little diagrams down here, I have the lateral faces and the bases labeled. To find the lateral area of this rectangular prism, we would be finding the area of this big rectangle that consists of those 4 lateral faces. So to find area of a rectangle, that's just base times height. So I have the height here. That's the length of that lateral edge. And then I have the length or the base of that rectangle that would fit all the way around the base of my prism. So the length of that rectangle is really the perimeter of our base, which is why we have a formula for lateral area of perimeter times height. So the P stands for perimeter of the base, and H stands for height of the prism. The height of a prism is always the length of a lateral edge. That's important to remember. Now, to find the total surface area, that's going to be the sum of the lateral faces, in other words, the lateral area, and then we have to add in the 2 bases that we didn't have before. So we just take our lateral area, which was P times H, and add in our 2 bases. So the area of the base is that big B. So we're finding the total surface area of that figure. Now let's practice this. So we're going to find the lateral surface area and total surface area of the figure below. We're going to use the shaded face as our base. Notice this is a rectangular prism. So we're going to find the perimeter of our rectangle that's our base first. So we have 8 plus 6. This dotted line here will be also 8, and this dotted line will be 6. So add up all of those sides and we get a perimeter of 28. To find the area of our base, the big B, we're going to find the area of the shaded rectangle. That's our base on this one. So 8 times 6 is 48. The height of the prism is the lateral edge. So notice here we have this gray base here. The top would also be a base. The length between them is 2. So the height of the prism is 2. Now that I have perimeter, base, and height, I need to just plug those into lateral area and total area. So lateral area is P times H, so 28 times 2, which is 56 square units. The total area is going to be the lateral area that we just found plus 2 of big B, which is 48. So when I add those together, I get 152 square units. So the lateral area, just the lateral faces of this rectangular prism, have an area of 56 square units. And the total area with the bases added in is 152 square units. Next, we want to find the lateral area and total surface area of this cube. In a cube, all of the surfaces are squares. And so we can find the perimeter of a square by adding all the sides. Since we know one side is 5, we know all of them are 5. So 5, 5, 5, and 5 gives us a perimeter of 20. Our big B, our area of the base, the area of this square is 5 times 5, which is going to be 25. The height of the prism is that lateral edge. So it's going to be 5 centimeters. Now I just plug in P, B, and H to the lateral area and total area formulas. P times H is 20 times 5, which gives us 100 square units. Total area is PH, which we already found, plus 2 times 25. So 100 plus 50 gives us 150 square units. In our next example, we have a triangular prism, and we're finding the perimeter of that base, then the area of that base, and the height of the prism. The perimeter of the base, we'll just add all our sides together, 10 plus 10 plus 12, which is going to be 32. To find the area of the base, we have to find the area of the triangle. The two triangles are our bases in the triangular prism. So the triangle has side lengths of 10 and 10 and then 12. If we make the height of that triangle, that's going to split that base in half and create 6 and 6. I know the area of a triangle has a formula of base times height divided by 2. So I already know the entire base is 12. I just need to find the height. So I'm going to use Pythagorean theorem. Once I've solved Pythagorean theorem, I find that the height of that triangle is 8. So I'm going to plug that into the area of a triangle formula. So I have 12 times 8 divided by 2. So 12 times 8 is 96. 96 divided by 2 is 48. So the area of that triangle is 48 square units. The height of this prism is that lateral edge between the two triangles, and so that is going to be 4. Now that I have P, B, and H, I just have to plug those into my formulas. So lateral area is going to be 32 times 4, which is 128 square units. Then I take the total area, which is PH, which was 128, plus 2 times 48, and I get 224 square units. Next we have a hexagonal prism. The bases are hexagons here. We're given one of the side lengths, and we're given the height of the prism, which is 12. We need to find P, B, and H to be able to find our lateral area and total area. We already know the height of the prism is 12, and we're going to use this hexagon to find the perimeter and area of the base. Since we have one of the side lengths already, we can just multiply by 6 to find that the perimeter is 36. Now I need to find the area of the base. Well, that's going to be the area of the hexagon. So I have to use the formula apothem times perimeter divided by 2. I know that the apothem is this dotted line here, and with the radius creates a 30, 60, 90 with the 60 at the corner. When I draw that apothem, it cuts the side in half to make a length of 3 here. That's going to be the 30, so the 60 is going to be 3 root 3. So the apothem is 3 root 3. I already know the perimeter of the hexagon is 36 from what I solved for before. So now I just plug in apothem and perimeter and divide by 2. So 3 times 36 is 108. 108 divided by 2 is 54, and then I have that square root of 3 on there as well. So the area of the base is 54 square roots of 3. Now I have to plug those values in to lateral area and total area. Lateral area is P times H, so that's 36 times 12, which is 432 square units. Now for the total area, I take my 432 from the lateral area and add it to 2 times 54 root 3. 54 root 3 was big B. 2 times 54 is 108, so that's 432 plus 108 root 3 square units. We do not combine like terms. This whole thing is my answer. 432 plus 108 root 3. Next we have a trapezoidal prism. I'm going to first find the perimeter of that base. So I can see I have all the sides here. So 6 plus 5 plus 12 plus 5 gives me a perimeter of 28. To find the area of that base, I have to find the area of the trapezoid. So the area of the trapezoid is base 1 plus base 2 times the height divided by 2. The two bases of the trapezoid are 12 and 6. The height was given to us of 4. So 12 plus 6 is 18. Divided by 2 is 9. 9 times 4 is 36. Now, I don't want you to get the B's and H's confused with these B and H's. These B's are the bases of the trapezoid, only of the two-dimensional figure. This H is the height of the trapezoid, the two-dimensional figure. This height here is the height of the prism. So the height of the prism is that lateral edge between the two bases, which is 10. Now that I have P, B, and H, I'm just going to plug those in. P times H is 28 times 10, which is 280 square units. Then I need to add in 2 times 36 to get my total area of 352 square units. Now we're going to talk about the parts of a cylinder so we can find the lateral area and total area. On this left-hand side, I have the net of a cylinder. So we have our two bases that are the two circles. Of that base, we have the radius of that circle. It's going to be useful in finding both circumference and area. This rectangle in the center here is the lateral, notice heavy quotations, face of the cylinder. And the height of the cylinder is the height of that rectangle that's created with that lateral face on the net. So this is going to be our height of our cylinder. The lateral area and total area formulas are exactly the same. We're just considering that we're finding the perimeter of a circle and the area of a circle. So when we look at lateral area and total surface area here, we're finding the perimeter of a circle, which is circumference. So we're given the radius of 3. So to find the perimeter of the circle, that's 2 pi r. So 2 times 3 pi is 6 pi. The area of the base is going to be the area of that circle. We find the area of a circle by pi r squared. So the radius is 3, squared is 9, so 9 pi is the area of that base. The height of the prism is the length between the two bases, and that is going to be 6. Now I'm still just plugging in P, B, and H to lateral area and total area. So perimeter times height is 6 pi times 6, which is 36 pi square units. Total area will be 36 pi plus 2 times big B. So we have 36 pi plus 18 pi. Those are like terms, so we can combine them. So 36 plus 18 gives us 54 pi square units.